So I'm back to show the rest of this problem regarding a little cart that is pushed by a spring and goes around a loop-the-loop. We started out our LOL diagram by showing that there was no energy in the cart at all at the start. Well, where was the energy? It was contained in the spring, but the spring wasn't in our system because the system was only the cart, the earth, and the track. So how does any energy get in the system? Well, it comes from the spring, and that is the arrow that I've shown right here. All right. So I should probably actually show that this is the spring. So let me see here, see if I can write spring right there. There I can. So there's a spring showing that that's coming from outside of the system, and that energy is getting added to the system. Now, you might say, well, aren't we creating energy? No, because the spring is, once it's done stretching out, once it's done pushing the cart, it's just sitting there. It has no more energy left in it. It can't push anything else anymore. It can only push something when it's squeezed tight together. All right, so now let's look and see what we end up with at the end. Well, we're drawing for the after situation when the cart was at the top of the loop. So it must have some gravitational potential energy. So I'm going to draw a G for gravitational potential energy. And I'm going to say that it has 2 bars of gravitational potential energy when it gets to the top of that loop. All right, so there's 2 bars of gravitational potential energy. Now, I already said that 4 bars of energy came in by working. So I have 2 bars left. Well, what's that going to be? Well, that will be kinetic energy, and that's going to be another 2 bars because we have to have 4 bars of energy ending up in that object in the cart. All right, so there's another 2 bars. Now, you might say, but what about thermal energy? And if I write this like that, a T for thermal energy, you might say, well, what about that? And my answer to that is this was a frictionless track. And because of that, there's no rubbing. And because of that, there's no energy being stored as thermal energy. If it were not a frictionless track, then there would be some energy as thermal energy. And so maybe it wouldn't be going as fast when it gets to the top of the hill. All right, so we need to write the equation here. And what you should write is that at the start, we got some work added to the system, and that work that we added to the system equaled our gravitational potential energy plus our kinetic energy. And so this is our before, and this is our after. All right. A lot of times on the left-hand side, you would have something else. Like, for example, maybe the car was starting out on top of a hill, and then a spring hit it. Well, then it would have had some gravitational potential energy at the start also, but it did not in this case.